Naturally, eyes first turned toward the Nevada. She was still afloat, but now her bright color was dimmed by a heavy coating of soot. That the bomb had missed the intended 0 point was soon obvious. Instrument measurements later showed that it had burst 710 yards short and to the left of the Nevada's foremast. This error was far greater than had been thought probable, nearly 4 times greater than the average error maintained in practice bombings. Exhaustive analysis of available photographs and other data has been made, but this analysis has not accounted for the error. A major bombing error was not completely unexpected. The target array and instrumentation were so devised that the location of the burst did not nullify the results of the test as far as graded damage was concerned. Protective margins allowed in positioning the ships and in distributing the instruments achieved recording of graded damage despite the magnitude of the error. The miss did prevent optimum functioning of many instruments. A line of sonobuoys designed to telemeter wave height was rendered useless. The projected 0 point was closest to the Gilliam, an APA. The Gilliam was one of the principal instrument-bearing target ships, and her loss had not been anticipated. She had been only 65 yards from the spot directly beneath the explosion. Within 1 minute after detonation, she sank. So badly ruptured, crumpled, and twisted was she that divers later found her barely recognizable as a ship. 4 other ships were mortally damaged and sank before re-entry or a short time later. These were the Carlisle, another APA, 430 yards from 0 point, the destroyer Anderson, 600 yards, the destroyer Lamson, 760 yards, and the new Japanese light cruiser, the Sakawa, which had been 420 yards from the center of the explosion. Heavily damaged and torn along the center line at the stern, which had faced 0 point, the Sakawa remained afloat for 25 hours before she sank. Of the 5 ships sunk, all had been within 760 yards of the center of detonation. The most conspicuous wreck still afloat was the USS Independence. Only the stamina which naval engineers had built into her as the first of the cruiser hull carriers allowed her to survive. Only 560 yards from blast center, she experienced a succession of serious fires and low-order explosions which rapidly developed aboard her. In heavy seas, she would have suffered progressive flooding from lack of water tightness above the waterline. Her military efficiency was virtually non-existent. Her bulkheads were buckled. Her hangar deck was a jumbled heap of rubble and ruin. Her warped flight deck was gashed and rent and had a crazy tilt. Both elevator platforms had been blown overboard by pressure trapped between decks. Nevertheless, her engines and boilers were relatively undamaged, and guided by tugs, she moved under her own power to a position for Test Baker. Even closer to the detonation, at 400 yards, was the submarine Skate. Demolished was her light superstructure, but interior damage was not sufficient to prevent her from getting underway. Yet her efficiency as a combat ship had been seriously impaired. Her radio and radar antennas were gone. Both her periscopes were inoperable. Her pressure hull proved how rugged are all ships of this submersible type. This inner strength hull was not substantially damaged, and no flooding resulted. She had been closer to the burst than 4 of the ships sunk. The stern of the Nevada was 615 yards from 0 point. Her superstructure was distorted. Her fire control antennas were beyond possible use. A portion of her main deck was dished in. Side casing panels on all of her boilers had been blown out. She needed steam to operate her power plant, her steering gear, and other equipment. This meant that it would be 24 hours or more before she could get underway at the slowest of speeds, even if a combat crew were aboard to perform the multiple tasks of repair. In an instant, her military efficiency had been destroyed. The Pensacola, 700 yards from point of detonation, would have required a voyage to port for extensive repairs before she would again be a fighting unit. Instruments revealed that she had been subjected to blast corresponding to a wind velocity of 384 knots. She had lost water tightness above the second deck, and her longitudinal structural strength had been slightly impaired. Her stacks were ruined, and her topside hatches had failed. Casings had been damaged in all 8 of her boilers. 3 additional ships had been immobilized, principally because of damage to boilers, superstructures, and stacks. These were the Arkansas, 620 yards, the Salt Lake City, 895 yards, and the Hughes, 920 yards from 0 point. Not immobilized, but suffering serious loss of military efficiency were the concrete YO-160 at 520 yards, the Crittenden and APA 595 yards, the ARDC-13 at 810 yards, the Dawson and APA 850 yards, the destroyer Rhine 1012 yards, the destroyer Talbot 1165 yards, the LST-52 1530 yards, and the Saratoga 2265 yards from 0 point, seemingly unscathed except for minor secondary fires. Yet the Saratoga's vital plane elevator had been jammed by the hammer-like blast from above. This indicated extreme vulnerability of elevators on old carriers to such form of attack. 9 other ships suffered moderate loss of military efficiency. They were the Nagato, 790 yards, the Brule, 990 yards, the YOG-83, 1035 yards, the Banner, 1190 yards, the Prinz Eugen, 1195 yards, the Barrow, 1340 yards, the New York, 1545 yards, the Pennsylvania, 1550 yards, and the Butte, 1990 yards. In summary, every ship within a half mile of 0 point had either been sunk or had suffered serious loss of military efficiency. Military efficiency of ships as far as 1,500 yards was impaired. One thing was clear: no pinpointing was necessary for a bomb of this type to wreak major damage. Naval experts studying the crippled ships readily saw that here lay a serious challenge to modification and redesign. It was to exposed surfaces and superstructures that the high-velocity air blast wrought its worst havoc, with destroyers proving the most vulnerable. Orientation to blast had important effects. Blast, reflected or focused into passageways and structural pockets, scored heavy damage. Reduction of damage from both blast and flash heat by even light shielding afforded an interesting study. In most cases of radar antenna damage, impairment was so great that repair work could not be accomplished at sea. Boiler damage meant reduced speed and impaired operation of ordnance and machinery. Significantly, the boilers of the modern carrier Independence were undamaged at 560 yards, although all 4 of her stacks were demolished. In general, modern boilers with double casings withstood the blast. Boiler vulnerability proved to be related to stack height and construction. Modern stacks of welded construction fared much better than older riveted stacks. Old boilers of American design proved extremely vulnerable to atomic blast. All of the old United States battleships suffered serious damage to boiler casings and brickwork. Strangely, the Nagato's boilers were unscathed. Damage to the Pensacola involved not only major boiler damage, but incipient failure of main hull structure, as evidenced by damage to main strength column supports in the engine room and the fire room. Her sister ship, the Salt Lake City, also had major boiler damage. The newer Prinz Eugen's boilers at 1,195 yards were undamaged, and the main visible damage was to superstructure. Even when stacks were damaged without accompanying boiler damage, the boilers could not be operated until repairs had been made or emergency stacks built. This meant immediate crippling of ships through loss of power. Extent of damage from blast down the stacks of a ship under full steam can only be contemplated. Electronic equipment was seriously damaged up to 1,200 yards and slightly damaged up to 2,500 yards. Principally, major damage was to wire radio antennas, bedspring-type antennas, and radar reflectors of light-gauge metal. Vacuum tubes and other delicate components remained generally undamaged by blast effects wherever they were securely shock-mounted. Metal tubes fared better than glass. Small, compact electronic equipment fared better than large equipment in resistance to the blast. Shock mounting, shielding, and streamlining proved their value. Within a radius of 900 yards of detonation, electrical equipment and instruments exposed topside suffered severe damage. In general, damage to electrical equipment was not one of the chief factors contributing to loss of military efficiency. Ordnance equipment on exposed vessels suffered little severe damage, although fire control systems were seriously affected by the loss of radar antennas. Optical systems stood up well. Modern rangefinders, normally rugged and shockproof, withstood the explosion with no internal damage. Range keepers, too, suffered light damage only. All exposed ammunition, as well as that in magazines, withstood the heat and blast virtually without change. Torpedoes, mines, and depth charges were not detonated. 12 torpedo warheads on the Independence, while not exploding, were consumed by the fires aboard and gave the flames new impetus. It was possible there was an ammunition or pyrotechnic explosion aboard the destroyer Anderson before she rolled over and sank. Packaged ammunition exposed for special testing remained undamaged at distances greater than 1,000 yards. Pyrotechnics in thin cases but otherwise unshielded were unaffected beyond 1,000 yards. Wrapped propelling charges and mortar powder increments in plastic cases, however, were damaged at distances up to 2,100 yards. Fuel and ammunition loadings for Able Day had been the subject of much discussion when the target array was planned. No fuel or ammunition fires occurred as the result of the burst. Fuel and ammunition loads varied from 15% to full. To prevent spreading of fires and loss of valuable instruments and experimental animals, vessels in the upwind sector carried the lighter loadings. Extending to the outer margins of the array, 27 fires had broken out aboard target ships at intervals after detonation. These fires were in exposed locations. All were extinguished by salvage crews except that aboard the Independence, which burned itself out. Many fires within 1,500 yards of zero point were snuffed out by winds associated with shock wave. Others smoldered for long intervals before bursting into active flame. Burlap wrappings of Army quartermaster material was a frequent source of fire. Jute and manila cordage burned readily. Induced heating from metal parts surrounded by combustibles caused scorching or fires. Scorch marks were found on combustible material on virtually every ship. Color, gloss, and reflectivity were definitely related to the inflammability of such material. Strikingly, fires were of much less importance in overall damage than they had been at Hiroshima and Nagasaki. Humidity differences, the presence of the cloud chamber effect, and the fact that ships are fundamentally fireproof were contributing factors. Fires in the sterns of the Sakawa and the Independence did create serious damage to these vessels, but not many other fires gained comparable headway. Salvage crews extinguished many blazes, but there were fires still burning when the sun went down on Able Day. No oil fires started in the water, although such fires had been feared. Seepage of oil did not commence until passage of the blast wave. Army tanks and heavy guns and mobile equipment suffered no impairment of operational efficiency beyond 600 yards. Unarmored vehicles, searchlights, and aircraft structures were damaged severely at ranges up to 1,200 yards, with minor damage as far out as 2,500 yards. Plastics were susceptible to the heat flash, which caused warping, fusing, and bubbling. Disintegration of laminations occurred where plastic bonding material had been used. Exploration was made of the degree of affinity of concrete for radioactivity and of resistance of concrete to blast. Baked paint in thin single layers on Army equipment withstood the heat of the blast much better than multiple layers of flat paint on decks and bulkheads. Ranges of scorching and blistering were irregular. Thermal screening by steam or fog undoubtedly contributed to this irregularity. Baled and packaged clothing was damaged by fire several miles from zero.